Team. So for today, we're going to log back into the test. Go ahead and press that green button. And then we want it to say guest, so we're going to leave it that way. Press sign in. I'm going to go ahead and select 11th grade. And we want to get back into the training test, so the second yellow one. Press this button. You don't need to change any of these things. Go ahead and just press select. Listen to that terrible sound. Ooh. Press I could hear it. Press continue. Press begin. So we're going to fast forward through the first 3 pages because we already did them. So just go ahead and click anything. Doesn't matter what you click. You just have to answer something. And then for this one, number 4, it says select all the equations that can be represented by a straight line when graphed on the coordinate plane. So they give us 6 equations here, and they want to know which ones are a straight line. So mathematically, you can know, like, if I'm dividing by x, or if I have y squared, or if I have x times x, that would be x squared. Those are all going to be not straight lines. If you would like to, the easiest way is you actually have a graphing calculator here. If you want to actually see them, you can just type them in. So you could just type 1 over x plus y equals 9. And you see, okay, that's not a straight line, so they do not want a straight line. So you can actually even go here and strike it out, say that's not a straight line, I don't like that one. Then you could say, okay, x equals 16 plus 3y. And I see this, and I can kind of zoom out and see, like, okay, that's a straight line. So that's a good answer. So I'm going to say, okay, I want to select that. Because it says select all, that means there could be more than one answer, so I actually individually have to check all of these. So like this one, I know it's y squared, so probably not going to be an answer. Negative 2y squared plus 7. You can see that green one, not a straight line, so that's not it. Go to this one, 8x minus 5y equals 30. That purple one is a straight line, so that's going to be an answer. I'm going to cross these out just to give me some more room. You can click this to go back to your like normal zoom. Y equals negative 6, x plus 10, something like that. I see it over here. I might zoom out. Yeah, I see a straight line, so I'm going to click that one. And then for the last one, y equals x 3 minus x plus 1. Right? Type them in. See how that one's not a straight line, so it's not going to be an answer. Right? So I know my 3 answers are this one, that one, and this one. So I'm going to go ahead and press save, and then I can move on to number 5. Cool. All right, for number 5, we have a table. We have to fill in something for each of these pieces here. So it says complete the table to show the number of students in each grade. Enter your answers in the table. So there are 500 total students. So I know these have to add up to 500. 17% of the total number of students are in first grade. So I can say, okay, in order to calculate a percentage, I know that I would do 7.17, right? Or you can do 17 over 100, like that. Same thing, 0.17 times, I know that there are 500 students, so I'm going to do times 500, gives me 85. So that they said that was in first grade, so I'm going to put 85 right here, like that. And it says 19% of the total number of students are in fourth grade. So I'm going to go back to my calculator. Instead of 17, I'm going to put 19%. 95 of them are in fourth grade. Cool. All right. The number of third grade students is 9 less than the number of fourth grade students. So there are less third graders than fourth grade. So if I take the 95 and I take away 9, I can do 95 minus 9. I get 86 third graders. Cool. All right, making my way through. The number of second grade students is 10 less than the number of fifth grade students. So I don't know how many fifth grade students are, so I can't subtract 10. So I'm thinking, okay, I know there's 500 total students, so I'm going to figure out how many do I have left for second grade and fifth grade. So I'm going to go to my calculator. I'm going to do the 500 total minus 85 first graders minus 86 third graders minus 95. So there are 234 students left over for second grade and for fifth grade. So I have to basically think of two numbers. It says second grade is 10 less than fifth grade, right? So they're like, the numbers are close to each other. If it was in half, I'd just like divide by 2. So that'd be like 117 and 117. But the numbers have to be 10 away from each other. So if I put this up at 27 though, it's going to add up to more than that 234. So think, okay, what could I add? If I add 2 here, I would have to take away 2 here. If I add another one to get to 120, I would have to take away another one to get to 114. So notice every time when I go up a few and down a few, still adding up to 234. So I have to get to where they're 10 apart though, 10 apart. So I could say, okay, make this 21, make this 113, make this 22, make this 112. Oh, look, they're 10 apart and they add up to 234. So it says second grade is 10 less than fifth grade. So second grade is a smaller number, 112, and fifth grade is the bigger number, 122. Cool. That's a hard one. You just have to work through like each piece by piece. Go ahead and press save, screenshot, turn it in. All right, 6. Cheryl claims that any irrational number squared will result in a rational number. Part A, drag an irrational number into the first response box that when squared will result in a rational number. Right, so what they want you to do is like drag this number into this box and a number into that box. You can drag it other places, but you want to like drag it into an answer box. Right? If you are like, no, that's the wrong one, you'll notice like if I try to drag it back, it doesn't delete. So you have to press this delete button and then press it and it will go away. Right? And then when you drag another one in, you can have it. So I'm going to delete both of those. So drag an irrational number. These are all irrational numbers over here into the box that when we square it, right? When we square it, it's going to result in a rational number. So irrational means like decimals that go on forever and ever. So if you look at your calculator here, if you type in like square root of 3 divided by square root of 2, you get this like crazy long decimal that goes on forever and ever. If we square it, so you take that whole thing to the power of 2, right? So I'd go here and say to the power of 2 like that. You get 1.5. Which is considered a rational number. A rational number is sort of like a basic number. It's a whole number by itself or something that can be divided by a fraction. The word rational really means fraction. So you can see like, okay, well, that's a fraction. This is not a fraction because when you divide them, they become irrational with this wild, crazy number here. So this one would be a good answer to fit into this one here where it becomes a rational number. An easier answer would be, go ahead and delete this, delete. Kind of hard to delete. Delete, okay, delete, there we go. An easier answer would be this one here because as you know, a square root and a square are going to cancel. It's going to leave you with just 2, like a normal number. So rational is like a normal number. Irrational is a crazy number. So we know pi is irrational. If we square pi, check out what happens. If I just type pi, and then if I square it, it's still a wild and crazy number. All right, so that is irrational. So wild and crazy numbers are irrational. So pi can go there. You could also put square root of pi in there. You can also put this one in here. You can also put this one in here. All of these answers be correct. You just want to put one of them in here. Then you're going to take your screenshot. Don't put any extras in there. That's not necessary. Just put these ones in here. Cool. That's number 6. All right. This one says the graph of x plus y equals -9 is shown. That's this one here. Use the add arrow tool. So this one right here. to graph the equation y equals 2x plus 3 on the same coordinate plane. So I'm going to graph 2x plus 3. So I'm going up. Remember, my 3 is my y-intercept. So up 1, 2, 3. Put a point there. And then it's 2 up 2 over 1, right? So we're going up 1, 2 over 1. You can put a point there. Up 1, 2 over 1. Like that. See how it, like, once I press it twice, so I can unclick this and go up higher if I want. Click again, go again, click again, go again. So it like extends my line. You have to click on the dot and then go backwards like this. Click and then click, click, and then if you want to go further, you can go down and over, down and over. It's kind of like those iExcel ones that we've done. Down and over like that, right? Notice if you're like back here, if you want to delete it, you can go ahead and delete. I think you click the point there. And then if you do like click on it and go here, click on it and keep going. And then if you do something like this, it will make it like crooked. So you want to make your line straight. So I'm going to delete that last part there. I'm going to add this arrow here. Cool. So I have my line here. And then it says use the add point tool, so this tool here, to plot the solution to this system of linear equations. Remember, solution means where they cross. So this is my solution right here. It looks like that's like a little off. So, oh, that might mean that my line is off. So since it's a little bit off, I'm going to check because this should go through +3. So I'm going to go ahead and delete this and that. I'll delete this. So I'm going to go back to add arrow, 3, up and over 2, over 2, click, 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 down and backwards, down and backwards. Aha, there we go. That's a nicer looking point there. All the way through. And I see that point there. So I'm going to go to add point and click that one there. This is the correct solution for number 7. Right. Press save. Then we'll go to our last one. Number 8. All right, number 8 says trapezoid A and trapezoid B are shown in the coordinate grid. Here they are. Describe 3 basic transformations, right? Basic transformations being rotation, translation, and what's the last one? There's dilation. So rotation means like orbiting around a circle, like going 90 degrees to the left or 90 degrees to the right. Translation means like moving up, down, sideways. And dilation is making bigger or smaller. Okay, bigger or smaller. So it says, describe the 3 basic transformations on trapezoid A, which show trapezoid B is similar to trapezoid A. In your response, be sure to identify the transformations in the order they would be performed. So this is just like a box, right? You can type whatever you want in this box. I think that it's easiest since they asked for like 3. I would say like 1, 2, 3, like that. And then it says we have to figure out how to make A into B. So they can go in whatever order you want. I would say I need to rotate it. Oh, there's also reflection, which is flipping over, right? So you have 3. You have flipping, which is reflection, rotating, you have translating, which is moving sideways, and you have dilation, which is big or small. This is from geometry. So I see here, in order to get it down here, I need to rotate it because I want the slanty part to be on top. So here I have this part. I want the slanty part to be going over there. So I'm going to rotate it, right? Remember, rotate like in a circle. I'm going to rotate it 90 degrees.
so that this part is over there. So I'd say first rotate 90 degrees, and we want to move it. We don't want to rotate it this way. We want to rotate it that way. We don't want this to go to the bottom. We want it to go to the top. So I'm moving in a counterclockwise direction, like opposite of the clock. So counterclockwise. Okay. So first thing, that's going to rotate it. So now that will rotate so that this is on top. And then from there, I need to move it down, right? So I'm going to say that I translate down. So this point right here will go down 1, 2, 3, 4, 5, 6, 7, down 7, and to the right 2. Right, so going down 7 to the right 2, down 7, and to the right 2. And then it will be too big once it gets over here, right? It'll be too big. So I'm going to dilate, right, smaller by a factor of, right now, this side, which will be the bottom, is 1, 2, 3, 4, 5, 6. And it's only 2 here. And then this is 3, and it goes down to 1. So I'm dilating by like 3 times by a factor of, and I want it to get smaller. So I'm going to say 1/3. 1/3. Right? This also, if I rotate 90 degrees counterclockwise, I want it to be around this point right here, -3, +3, around point -3, +3. This is probably like the most specific that you would want to be, or like that you can be in this case. This is also not the only way you could do it. So if you can think of another way to make A turn into B, that can be right as well. Right? If all you can do is list out like rotate, translate, and dilate, that's okay too. You can get some partial points by doing that. Right? So it doesn't have to be this exact. So I'm going to get rid of this part. So the point in this box is just to write as much as you can to answer the question, even if you think you're totally wrong. Definitely just keep writing. So then you're going to take a screenshot of this and then press save. It'll say, next, you've reached the end of the test. Woohoo. Press OK. And then you're going to go ahead and press end test. You say yes. And that's it. It'll say like you have 1 through 8. You can press submit. On the day of the test, this is what you'll do. And you'll see test summary, and it'll say that you are all done. And that's it. You'll log out. And you're good to go. Thanks, y'all.